Welcome students, welcome to Industrial Fluid Power session. This session we are going to see about the components of hydraulic systems. Under this we are going to see this hydraulic actuators. So hydraulic actuators, we are going to see the actuators constructions, working and symbol of rotary actuators, hydraulic motors, linear actuators, cylinders, single acting, double acting cylinders. So hydraulic actuators. What is hydraulic actuators? Hydraulic actuators are devices used to convert pressure energy of the fluid into mechanical energy. So depending on the type of actuation, hydraulic actuators are classified as follows. Linear actuator for linear actuation, hydraulic cylinders, and rotary actuator for rotary actuation like hydraulic motors. Semi-rotary actuator for limited angle of actuation, that is semi-rotary actuator. So now let's going to see about the linear actuator. This is how this linear actuator industrially practically looks like. And this is the rotary actuator it looks like. And this is the semi-rotary actuator. It's look like it having a linear as well as the rotary motion with the help of this rack and pinion gear motion. So now we are going to see about the selection parameters for actuators. So these are the following factors to be considered while selecting the hydraulic actuators are as follows. First one is the stroke length required and the speed needed and the force needed. How much is the speed and force needed? How much is the flow rate of compressed air? How much pressure of compressed air? And the size of cylinder and the material of components. And what are the types of hydraulic cylinders? So hydraulic cylinders are of the following types. First one is single acting and double acting cylinders, telescopic cylinders and tandem cylinders. So single acting cylinders. This is the actual image of the single acting cylinder. This is the schematic image of the single acting cylinder. In single acting cylinder, you are having a one inlet port, that is a pressure port, and one more vent port, and it is connected with the piston rod and spring concept. Okay, here you are having an extension stroke and the return stroke. The extension stroke is with the help of the extension stroke is happening with the help of the pressurized fluid, but for the return stroke it is going with the help of spring. A single acting cylinder is simplest in design and is shown schematically in this figure. So it consists of a piston inside a cylindrical housing called barrel. On one end of the piston there is a rod which can reciprocate. At the opposite end there is a port for the entrance and exit of oil. So in single acting cylinders, the single acting cylinders produce force in one direction by hydraulic pressure acting on the piston. So this force in one direction by hydraulic pressure acting on the piston. So single acting cylinders can exert a force in the extending direction only. So this can exert a force in this extending direction only. Okay. So the return of the piston is not done hydraulically. In single acting cylinders, the retraction is done either by gravity or by a spring. Okay. So in single acting cylinder, only one side force exertion is happening. The return side is done either by gravity or by a spring. So let's see about the double acting cylinder. So there are two types of double acting cylinders. Double acting cylinder with a piston rod on one side and double acting cylinder with a piston rod on both sides. So this is how the double acting cylinder looks like. So this is a double acting cylinder with a piston rod on one side. Okay. So double acting cylinder with a piston rod on one side. Let's see. So this figure shows the operation of a double acting cylinder with a piston rod on one side. Okay. So here having a piston rod on one side only. So to extend the cylinder, the pump flow is sent to the blank end port as shown in figure. So in order to move the piston, this pump flow, that is the pressurized fluid has to send in one direction. That's the hydraulic fluid send in one direction, so that the piston will move to the extend to the this towards right hand side from left to right. Now the fluid from the rod and port returns to the reservoir. So when the piston rod moving from this direction, the oil enters in this way, this rod side is moving. The oil in the rod side will move down and it go to the return flow. Okay, so to retract the cylinder, the pump flow is sent to the rod and port, and the fluid from the blank and port returns to the tank. So in order to doing return stroke, here no gravity motion or no spring option. For return stroke, here return stroke is also done by the hydraulic fluid only. So the pump, the pressurized fluid will send through the rod inside, and from the blank inside, that oil will return to the return tank. And the double acting cylinder with a piston rod on both sides. So here this is look like a double acting cylinder with a piston rod on both sides. So this is how the real cylinder look like. So a double acting cylinder with a piston rod on both sides is a cylinder with rod extending from both sides. This cylinder can be used in an application where work can be done by both ends of the cylinder, thereby making the cylinder more productive. So by using this rod at the both the end, you can get the work, you can extract the work on both the sides. Okay, so that the work may be more productive. So the double rod cylinders can withstand higher size loads because they have an extra bearing, one on each rod to withstand the loading. Okay. Now let's see the how the single acting cylinder and double acting cylinders work in a short video.
What's the difference between a single acting and double acting hydraulic cylinder? In this video, we will explain the difference between a single acting hydraulic cylinder and a double acting hydraulic cylinder. A single acting cylinder has a piston rod, a cylinder barrel, a hydraulic seal, and normally a bearing to limit how far it pumps out. When you feed oil or your hydraulic fluid into it through the inlet port, it will extend, exerting a force, in this case, lifting a mass. In this example, we're using a micropack hand pump to provide the pressurized fluid. Hand pumps are low-tech and easy, but you could alternatively use an electric pump or air-driven pump. When it has done its work, you need to release the fluid back into the tank. To do this, we fitted a needle valve into the micropack hand pump. You open the valve and the oil flows, letting the mass drop. You always need a way of returning the cylinder, either gravity return or use a spring. So the single acting cylinder will pump out, doing its work, and retract when the fluid is released back into the tank, in and out. A double acting cylinder will allow you to push and pull under hydraulic power. You've got a smaller piston rod with a seal on a piston. You have a cylinder barrel and a piston rod bearing with an extra seal. This forms a second hydraulic chamber. You'll need a four-way directional control valve to operate your double-acting cylinder. We've added one to our micropack hand pump. There are two connections on this valve, one at either end of the cylinder. Pressurize the bottom of the ram or full bore end to generate force. You need to connect the upper chamber or reduced bore to the tank, or the ram will jam. You can see the ram is now extending. At the end of the stroke, we are reversing the four-way valve, so the pressure feed is now connected to the reduced bore end. We can now retract the ram under power and pull the rod back. It doesn't need a spring or gravity to return it. The force generated by the hydraulics will be smaller because the area is smaller. Now you've seen single and double acting hydraulic cylinders, or hydraulic rams, in action. A simpler single-acting cylinder that needs gravity return, and the more complex double-acting ram that provides force in both directions. At Serum Hydraulics, we supply micropack manual pumps to operate single and double-acting cylinders. And as the hand pump experts, we've got solutions for a wide range of demanding applications. Talk to us today or find out more at serum-hydraulics.co.uk.
Now let's see the one more video for this hydraulic actuators.
The purpose of a fluid system is to transmit power from one location to another. Fluid power is converted to mechanical power by means of an actuator. Cylinder actuators deliver a linear push-pull motion via a rod and piston within a cylindrical tube. A single-acting cylinder is a cylinder in which the working fluid acts on only one side of the piston. The other side of the cylinder utilizes a mechanical load, springs, compressed air, other cylinders, or the momentum of a flywheel to push the piston back in the other direction. This particular cylinder utilizes a spring on the non-fluid side. A single-acting cylinder produces linear motion in one direction. When a control valve directs fluid through the inlet port into the blind end, pressure builds up and generates a force on the piston. When the pressure buildup is large enough, the piston begins to move, extending the rod. This is called the forward stroke. When a control valve directs fluid out of the port, the fluid pressure is removed. The force of the spring pushes against the piston in the other direction, and the rod returns to the cylinder. This is called the retraction stroke. Single-acting cylinders are most often found in reciprocating engines, pumps, and hydraulic rams. A double-acting cylinder is a cylinder in which fluid acts on both sides of the piston. This type of cylinder can produce linear motion in two directions. A double-acting cylinder has two fluid ports, one on the blind end and one on the rod end. A directional control valve sends fluid through the blind end port while venting fluid out the rod end port back to the tank. Pressure builds up and generates a force on the piston, causing the extension stroke. When the directional control valve is shifted, it sends fluid into the rod end port, out of the blind end port, and back to the tank. Pressure builds up and generates a force on the other side of the piston, causing the retraction stroke. To determine the speed of a piston during extension and retraction, we must first determine the significant working areas. The full piston area is the side of the piston without the rod. This is the area that feels pressure as the piston extends. The next significant working area is called the net area. This area is the size of the full piston area minus the area of the rod. The net area feels pressure when the cylinder retracts. The speed at which the piston extends and retracts is calculated using the volumetric flow rate divided by the area for the incoming fluid. Since each side of the cylinder has a different working area, each side experiences a different speed. Let's assume that the volumetric flow rate is equal for each inlet. Because the rod takes up space within the cylinder, less fluid is required to fill that side. This means that the fluid can fill the rod end side more quickly than it can fill the blind end. Since the rod end side fills with fluid more quickly, the cylinder will always retract faster than it can extend. All the cylinders shown to this point have been single-ended. They have only one working rod. On special cylinders, two rods may be used. These are called double-ended cylinders. They have two rods, both attached to the piston, and each coming through an end cap. Double-ended cylinders work similarly to single-ended, but are used when a constant speed is required for both the extension and retraction strokes. Since the flow rate is the same and the piston areas are the same, the speed for extension and retraction is also the same. Due to their simple design, cylinders are used more often than any other type of actuator for industrial applications. Although their motion is linear, it can be converted to rotary motion by levers, racks and pinions, or other means, making them one of the most versatile types of actuator.
So now let's see about the telescopic cylinder. A telescopic cylinder is used when a long stroke length and a short retracted length are required. Okay, a telescopic cylinder extends in stages, each stage consisting of a sleeve that fits inside the previous stage. One application for this type of cylinder is raising a dump truck bed. Telescopic cylinders are available in both single acting and double acting models. They are more expensive than standard cylinders due to their more complex construction. So this is how this telescopic cylinders looks like. So actual telescopic cylinders look like this. So they generally consist of a nest of tubes and operate on the displacement principle. So the tubes are supported by bearing rings, the innermost set of which have grooves or channel to allow fluid flow. The front bearing assembly on each section includes seals and wiper rings. Stop rings limit Stop rings limit the movement of each section, thus preventing separation. When the cylinder extends, all the section moves together until the outer section is prevented from further extension by its stop ring. The remaining section continue outstroking until the second outermost section reaches the limit of its stroke. So this process continues until all sections are extended, the innermost one being the last of all. Now let's see how this telescopic cylinder works in this video. Let's see. Let's see one more video for the telescopic cylinder, how it workings. This is the truck telescopic cylinder used in the truck. So this is how this telescopic cylinder extends one after the other. Now let's come back to the tandem cylinder. So this is how the tandem cylinder looks. A tandem cylinder shown in figure is used in applications where a large number of forces is required for small diameter cylinder. So by using the small diameter cylinder, wherever we need a large force required, we can go for this tandem cylinder. So pressure is applied to both pistons. So you can see the tandem cylinders. You're having a two portions, one partition. It separate the two pistons. So here one piston rod is there. Here one piston rod is a center is a partition. So both the piston rod is connected in serial. So wherever the high force required, we can use a small cylinder with to produce high force. So the pressurized fluid from the tank is go through this port and as well as this port. Okay, resulting in increased force because of the larger area. So the drawback is that this cylinder must be longer than a standard cylinder to achieve an equal speed because flow must go to both the pistons. Okay, so but the thing is we can use it for a small, we can consider it as a smaller cylinder, but the length will be longer, it will not be shorter. So whenever we need a tandem cylinder or whenever we need a small diameter but a high force, we have to go for the lengther one. This is how the actual tandem cylinder looks. So these are the some of the symbols used for the uh, actuators, hydraulic actuators. So this is the symbol used for the single acting cylinder with unspecified return, and this is the single acting cylinder with spring return. Single acting means only one port is there for extension and retention. Both the oil will come and go in this port itself. So this is the double acting cylinder with single piston rod, one for inlet, one for return. And this is the double acting cylinder with a double piston rod. Okay, and this is the telescopic cylinder double acting, so one inlet and one outlet. And this is the telescopic cylinder single acting, and this is the double acting cylinder fixed cushion on one side. This is the cushion, and this is the double acting cylinder with variable cushion. This arrow indicates the variable cushion on one side, and this is the double acting cylinder with variable cushion on both sides. This cushion they keep it in the center, so it is considered as a variable cushion on both the sides. So let's thank you students. Thank you for watching this video. We'll see you in the next class.